Imagine a world entirely covered by a dark, violent ocean, hundreds of miles deep. Above it, a thick alien atmosphere traps the heat of a distant, red sun. There are no continents, no trees, no dry land at all. Just endless waves under a crimson sky. For decades, this was just a painting in a science fiction book. But the James Webb Space Telescope has just looked 120 light-years into the void and found something that shouldn't be there. It didn't just find the planet. It found a chemical shriek coming from the atmosphere, a molecule that on Earth is only produced by one thing: life. We are no longer looking at a dead rock. We might be looking at the first confirmed alien ecosystem in human history. But how did we get here? And why is the scientific community currently holding its breath, terrified of being wrong, but desperate to be right? To understand the magnitude of this, you have to realize how much of a blind spot we've had for the last century. Space is a graveyard of silent worlds. Our galaxy is packed with billions of planets, but until now, they've been nothing more than shadows. We knew they were there because they blocked a bit of starlight, but we had no idea what they were made of. They were silhouettes in the dark. Before Webb, trying to find life on a distant planet was like trying to identify the color of a bird's eyes from 5 miles away. In a blizzard, using a pair of cracked binoculars, we could see the bird, but the details were impossible to catch. That's because life is subtle. It doesn't send us a radio signal or build giant neon signs. Instead, it breathes, it decays, it leaves a chemical footprint in the air that lingers for millions of years. These are called biosignatures, and for the first time, we have a machine powerful enough to sniff them out. The James Webb Space Telescope is that machine. It doesn't see the universe the way you and I do. It sees in infrared, the realm of heat and hidden energy. When a planet passes in front of its star, a tiny microscopic sliver of starlight filters through that planet's air. Webb catches that light, breaks it apart into a spectrum, and reads it like a barcode. If there's water, Webb sees it. If there's methane, Webb sees it. And if there's something stranger, Webb is the only thing in existence that can tell us. Before we dive into the specific planet that is currently breaking the internet, if you want to stay updated on the most mind-bending discoveries from the edge of our universe, make sure to hit that subscribe button and turn on notifications. We're living in the golden age of space exploration, and you don't want to miss the moment we finally find what we're looking for. Now, let's talk about the world that has everyone talking. K218b is a sub-Neptune sitting right in the Goldilocks zone of its star. Not too hot, not too cold, but just right for liquid water. But it's not like Earth. It's 8 times the mass of our home. Scientists believe it's a Hyson world, a portmanteau of hydrogen and ocean. Imagine a planet where the atmosphere is mostly hydrogen, creating a massive greenhouse effect that keeps a global, planet-wide ocean liquid and warm. When Webb pointed its golden mirrors at K218b, it found exactly what you'd hope for: carbon dioxide and methane. That combination suggests a carbon cycle, which is a huge green flag for habitability. But then buried deep in the data was a ghost, a signal for dimethyl sulfide, or DMS. This is the holy grail moment. On Earth, there is no known natural geological process that creates DMS. It isn't made by volcanoes. It isn't made by lightning. It is made by phytoplankton in the oceans. It is a waste product of life. If the detection of DMS is confirmed, it means that 120 light-years away, something is living in those dark alien waters. Something is breathing. Something is eating. But we have to be careful. This is where the strategy of science kicks in. We can't just claim aliens and go home. The signal for DMS is faint. It's right at the edge of what Webb can detect. It's like hearing a whisper in a crowded stadium. You think you heard your name, but you need to hear it again to be sure. The scientific community is currently split. Some believe the data is a clear sign of a biological process. Others argue that we don't fully understand the chemistry of Hycean worlds yet. Maybe hydrogen-rich atmospheres can create DMS through some weird high-pressure reaction we haven't discovered in a lab yet. This is the tension of modern discovery. We are standing on the shoreline of a new era, looking out at a horizon we can finally see, but we aren't quite sure if that shape in the distance is a ship or just a cloud. So, what would life on K2-18b actually look like? It wouldn't be little green men in flying saucers. Because the planet is so much larger than Earth, the gravity would be crushing. The atmosphere is thick and heavy. If life exists there, it's likely microbial. Billions of tiny organisms floating in the upper layers of the ocean, soaking up the faint infrared light from their red dwarf star. But don't let microbial bore you. Remember, for the first 3 billion years of Earth's history, we only had microbes. They are the foundation. If we find even a single bacteria on another world, it means the universe is teeming with life. It means life isn't a miracle, it's a statistical certainty. It means that everywhere there is water and energy, there is a soul. The implications are staggering. If K2-18b has life, then what about the TRAPPIST-1 system? What about the thousands of other exoplanets Webb hasn't even looked at yet? We are currently looking at less than 0.00001% of the map. The James Webb Space Telescope is essentially a time machine and a biological sensor wrapped in gold foil. It is showing us that the boring dots of light in the night sky are actually vibrant, chemical, and potentially living worlds. But there are risks to this kind of news. We've seen alien life found headlines before that turned out to be false alarms. In the 1990s, a Martian meteorite seemed to have fossils, but it was later debated. Recently, phosphine was found in the clouds of Venus, another potential biosignature, but that data is still being fought over in the halls of academia. The danger is science fatigue. If we keep saying maybe life and it turns out to be just a rock, people stop caring. That's why the Webb team is being so quiet. They are running the numbers again. They're scheduled for more deep-look observations of K2-18b. They want to see if that DMS signal gets stronger or if it disappears like a ghost in the machine. But even if K2-18b turns out to be a false positive, the technology has been proven. We now know we can see these molecules. We know the barcode is readable. If it's not this planet, it will be the next one, or the one after that. We are the first generation of humans who don't have to guess if there is life out there. We can just look. Think about the scale of that for a second. For 200,000 years, humans have looked at the stars and wondered. We built mythologies, religions, and philosophies around the loneliness of being the only living thing in a cold, dead cosmos. And now, in a random year in the 21st century, a bunch of engineers launched a giant folding mirror into deep space, and it whispered back, "I found something. The first confirmed alien life could be discovered in your lifetime. Not in 100 years, not in 1,000, possibly in the next few months." Webb is only at the beginning of its mission. It has enough fuel to last for 20 years. It is currently scanning the atmospheres of planets that are even more Earth-like than K2-18b. It is looking at the ice giants, the lava worlds, and the diamond planets. Every time the data comes back, we learn that the universe is weirder, wetter, and more active than we ever dreamed. So, as we wait for the final confirmation on K2-18b, we have to ask ourselves, are we ready? Are we ready to no longer be the center of the universe? Are we ready to share the galaxy with 1 billion other oceans, all teeming with their own strange, microscopic versions of history? The James Webb Space Telescope didn't just find a planet that might be alive. It found a mirror. And when we look into it, we realize that we aren't just observers of the universe. We are a part of a much, much larger family. The search continues. The data is flowing. And the next discovery might be the one that changes everything forever. Stay curious. The universe is much louder than it looks.